Today I'm here to explain about this question. Find the horizontal asymptote of each rational function. So first of all, you have to know the word horizontal asymptote. I've explained about it before, but let me explain about it again. So asymptote is the line which the graph is getting close to but never touches or crosses. For example, if the graph is like this, when x value of this graph is getting so bigger, it's close to this value, right? But it's never touches, but it's getting pretty close to it. This line is called asymptote, and in this case, this asymptote is horizontal, so it's called horizontal asymptote. On the other hand, for example, if like this, when x value is gets really small, and if the y value is like this, you can find the asymptote here as well. This is vertical asymptote, but it has nothing to do with it in this case, in this question. So let's just focus on horizontal asymptote. But how do you find horizontal asymptote? It's actually pretty simple. What you have to do is you try to find the value of y when x is really small, which means when x value is getting close to infinity or negative infinity, like that. Then you try to find the value. If the value is infinity, which means the graph is somehow like this, this means it doesn't have any horizontal asymptote because it doesn't getting close to any value. It's just getting bigger and bigger. Okay. Then let's try to work on number 1, y equal 1 over x plus 1. When x value approaches infinity or negative infinity, it's going to be 1 over infinity. You know, this one, you can assume this one is 0. So in this case, this means when x is really big or really small, the value of y is getting close to 0, like this. So the answer is y equal 0. This is horizontal asymptote. Okay? Then let's work on number 2. Y equal 1 over x squared over 2 squared plus 1. And limit x approaches plus minus infinity. Do you remember what you have to do in this case? Yes. So what you have to do is divide by the highest power of denominator, which is x squared. So let's try it. 1 over x squared, negative 1. 2 plus 1 over x squared. And when x approaches infinity, limit 1 over x squared as x approaches infinity. This is 0 because 1 over infinity is getting close to 0. So you can assume these are 0. So the leftover is these, negative 1 over 2. So the answer is y equal negative 1 over 2. Okay, then let's work on one more question. Number 3, y equals 3x to the power 5 plus 2x negative 3 over x to the power 4 negative x plus 1. So let's do the same way as number 2 again. You have to divide by the highest power of denominator, which is x to the power 4. So let's do it. 3x plus 2 over x cubed negative 3 over x to to the power 4 over 1 minus x 1 over x cubed plus 1 over x to the power 4. And again, you can assume these are 0, so you can just cancel out, and left over is these. And 3x as x approaches infinity or negative infinity, which is infinity over 1. So this is infinity. This means it doesn't have any horizontal asymptote, so it doesn't exist. So no horizontal asymptote in this equation. Okay, that's all.